Hello students, this video on chapter 2 units and measurements. Topics to be covered in this lesson: physical quantity, fundamental and derived quantities, characteristics of standard units, FPS, CGS, MKS and SI system of units, definition of fundamental SI units, measurement of length, large distances and small distances, measurement of mass and measurement of time, accuracy, precision of instruments and errors in measurements, systematic errors and random errors, absolute error, relative error and percentage error, combination of errors in addition, subtraction, multiplication, division, significant figures, scientific notations and rounding of uncertain digits, dimensions, dimensional formula and dimensional equations, and dimensional analysis, its application and demerits. Now, let us study about a physical quantity. Physics is a quantitative science where we measure various physical quantities during experiment. In our day-to-day life, we need to measure a number of quantities. Example, size of objects, volume of liquid, amount of matter, body temperature, etc. So, a quantity which is measurable is called physical quantity. So, what is physical quantity? A quantity which is measurable. So, quantity which is measurable is called physical quantity. Now, let us see what is fundamental quantity. A physical quantity which is the base. Fundamental in the sense it is base. A physical quantity which is a base and cannot be derived from any other quantity is called fundamental quantity. So, fundamental quantities are base quantities and it cannot be derived from any other quantities is called fundamental quantity. Examples: length, mass, time. So these are length, mass, time. These are all fundamental quantities. The next one, a derived quantity. A physical quantity which can be derived or expressed from a base or fundamental quantity. Such a quantities are called derived quantity. So the derived quantities are nothing but they are derived from our base quantities. Derived quantities are derived from our base quantities. Such a quantities are called derived quantity. Examples: speed, velocity, acceleration, force, momentum, torque, energy, pressure, density, thermal conductivity, resistance, magnetic moment, etc. So we have many derived quantities, but we have only few fundamental quantities. What is physical quantity? A quantity which is measurable. Any quantity If it is measurable, then it is called physical quantity. In the physical quantity, we can see fundamental quantity and derived quantity. The fundamental quantities are base quantities, a physical quantity which is a base and cannot be derived from any other quantities are called fundamental quantity. Derived quantity, a physical quantity which can be derived from a base quantity or fundamental quantities are called derived quantity. Now let us study about units. So what is an unit? Internationally accepted reference standard to measure a physical quantity. So it is internationally accepted reference standard to measure a physical quantity is called unit. So when we talk about physics, we have several physical quantities. So we need a reference to measure our physical quantities. For example, your mom asked you to go to the shop and buy some rice. Now, how would you convey the shopkeeper how much rice you want? So you need a unit to identify the measurement of the rice. You go to the shopkeeper and you say you want a 5 kg rice. So here kg is internationally accepted reference which everybody understand. Similarly, we can give an example for a kilogram. Kilogram, which is the unit for mass. Meter is a unit for length, etc. So these are the some of the example for the units. So what is unit? Unit is internationally accepted reference. A standard is called unit. Now units are classified into two types. One is fundamental units and second one is derived units. Now fundamental units, which is also called a base units. The fundamental units are those units on the basis of which all the other units are defined. So here we have a definition. The units of the fundamental or base quantities are called fundamental or base units. So here the fundamental units are those units on the basis of which all the other units are defined, isn't it? So there are 7 fundamental units. Now here we have a few examples like meter, kilogram, second, etc. So these are all fundamental units. Now the second types is a derived units. The units of the derived quantities which can be expressed from the base or fundamental quantities are called derived units. So derived units are always derived from fundamental units. Here is their origin is fundamental units. So what are derived units? A unit of derived quantity which can be expressed from the base quantities are called derived units. Example, here it is having example meter per second. where the meter is the unit for length and second is the unit for time. Those are base quantities. So the unit meter per second is a derived units. For example, meter square. It is a unit for area. Meter square is a unit for area. Now meter is the fundamental unit and meter square is derived unit. So here we have a few examples. Kg per meter cube. So kg and meter, they are base units. So kg per meter cube is derived units. So those are example for a derived units. Now let us study a system of units. A complete set of both fundamental and derived unit is known as system of units. So system of unit in the sense a complete set of both fundamental and derived unit. Fundamental and derived unit together it forms a system of units. SI unit, the system international. SI units, a system international. SI unit means it is system international, a globally accepted system for a measurement. So here we have a various system of units. In earlier time, various systems like FPS, CGS and MKS system of units were used for a measurement. They were named so from the fundamental units in their respective system as given below. So the quantity, we are having the columns here: quantity, dimension and system of units. So there are three system of units. What are they? CGS, FPS and MKS system. Now the quantities: length, mass, time. The dimension that I will explain later in the next class. Okay. Now FPS. F stands for foot, pound and second. FPS, foot, pound, second. So here length, mass, time are in terms of foot, pound and seconds. Next one, in a CGS system units for length, mass and time are centimeter, gram and second. In MKS system, the length, mass, time are measured in meter, kilogram and second. So in present, the system of units which is at present internationally accepted for a measurement is the abbreviation is SI. That means a system international. System international. So it is called a system international D units. So abbreviation SI units. Or else we can, in simple we can say it is a system international units. So the SI is a present internationally accepted a standard reference. In SI system there are 7 base units and 2 supplementary units, and there are many derived units. In SI system there are 7 base units and 2 supplementary units, and there are many derived units. Now the base quantities. So here the fundamental units, that is base units, and the 7 base units, what are they? Length, mass, time, electric current, thermal temperature, light intensity, amount of substance. So these are all quantity, physical quantities. Their representation in the symbol. Length is represented by L, their SI unit is meter. In symbol meter we can write M. Mass, symbol capital M. Kilogram, SI unit is kilogram, the symbol of kilogram is kg. Time, symbol is capital T. Sometimes you will write small t also. SI unit second and symbol small s. Electric current, symbol capital A, SI unit ampere, symbol capital A. Temperature, symbol capital K, SI unit Kelvin, symbol capital K. Light intensity, symbol capital C and small d. SI unit candela, symbol CD, both are small letters. Amount of substance, symbol mole, SI units mole and symbol MOL, mole. So these are 7 fundamental quantities and units of SI systems. So there are 7 fundamental units, and we have 2 supplementary units. One is plane angle and another one is solid angle. So the plane angle, the symbol is d theta, SI unit is radian, symbol RAD, it is RAD. Solid angle d omega, SI unit steradian, symbol small s and R. These are the 2 supplementary units. So how many fundamental units we have? We have 7 fundamental units. What are the 2 supplementary units? Those are radian and steradian. We have many derived units. Now let us see what are the supplementary quantities of SI system, that is radian and steradian. Now here let us see the plane angle and solid angle. The plane angle is d theta, is a ratio of arc ds to the radius r. Its SI unit is radian. So the radian is to measure the angle in a plane. Radian is used to measure angle in a plane, whereas steradian is used to measure a solid angle. So radian is used to measure plane angle and steradian is used to measure a solid angle. So plane angle d theta, it is the ratio of arc of length ds to the radius. So in given picture you can observe here arc is ds, to the radius is small r. So d theta is a plane angle. So plane angle d theta, it's a ratio of arc to the radius. Plane angle is a ratio, it is a ratio of arc to the radius. Its SI unit for a plane angle is radian. Radian is used to measure a plane angle. Now the next one, solid angle. SI unit for a solid angle is steradian. Steradian is used to measure a solid angle. Now here it is for a solid angle. It is represented by d omega. D omega is a ratio of intercepted area, that is dA, to the square of radius. So d omega is equal to dA by r square, that is d omega, that is the solid angle is a ratio of intercepted area dA to the square of radius. So here the solid angle d omega is a ratio of intercepted area dA of the spherical surface described at the apex O has a center to the square of its radius r. Its SI unit is steradian. Students, you have to refer your notes, okay, for the diagram. Now the next one, the following conventions are adopted while writing units. So the derived units, there are many derived units. Some of them are force is a physical quantity, its unit is Newton. Work, energy, its unit is joule. Power, unit is watt. Frequency, unit is hertz. So certain derived units are expressed by means of special names, like such as joule, Newton, watt, etc. They are named so as to remember the names of scientists worked in that field. So here, while writing a unit, we have to follow following steps. Okay, the first one, even if a unit is named after a person, a person is the scientist, the unit is not written in a capital letter. That is, we write joules is not joules. So here we have to write then SI unit. We know that joule is a unit for a work, isn't it? So while you are writing the unit, you have to write a small letter J, not in a capital letter. Okay, so if the unit is named after a person, then the unit is not written in a capital letter. So the starting letter must be we have to write the letter in a small letters, not in a capital one. The second one, for a unit named after a person, the symbol is a capital letter. Example, for a joules, we write J and the rest of them are in lowercase letters. Example, second is written as small s. So if you are writing the unit has a in symbol representation. For example, unit is joule, isn't it? But in symbol we have to write a capital letter J, not a small letter. If you are writing the complete name of the person, like the force, the unit is Newton. While writing the Newton, you have to write a small letters. All the letters are in the lowercase. While you are writing the symbol, you have to write a capital letter. So Newton, you have to write the symbolical representation is capital letter N. The third one, the symbols of units do not have a plural form, that is 70 meter, not 70 ms. So, or we can say 10 Newton, not 10 Newton s. So here the symbols of unit do not have any plural form. We cannot write 70 meter s. Okay. So we have to write it is 70 meter. So plural in the sense understood, right? The dog, dogs. So while you are writing s in the sense it's a plural form. So such a plural form is not applied for a units. The last one, punctuation marks are not written after the units. So here it is an example, 1 liter is equal to 1000 cc. You should not supposed to write C 1000 C dot C dot. Okay, there is no any punctuation marks. You have to write 1 liter is equal to 1000 cc. Is it clear? Is there any doubt? You can text me in the WhatsApp. Okay. So these are in today's class what we learned. We learned what is physical quantity, what are fundamental quantities and base quantities, what are units, then base quantities, supplementary quantities, and the following conventions are adopted while writing the units. So that what we studied today's class. The lesson will be continues, okay, in the next video. Thank you. Have a good day.